So I'm having a total experience of 3 years in teaching KCET category students. So hope you will there till the session end, so that I will clear the concepts of Kirchoff's voltage law and current law. So we had one problem for Kirchoff's voltage law in the previous session. So in this session, I will go for remaining problems which are very important for NCERT board exams. So that we will discuss today. Okay. So before going for the session, let me give a small information regarding an Academy Plus plan. This is for Karnataka CET 2021 compressive batches and live on Unacademy Plus. And the beneficiaries we give for the students is like complete syllabus will be covered, tips and tricks given by the top educators from the part of Karnataka, topic wise practice questions and even full length mock test. Everything will be covered under Unacademy Plus. So the plan is like a 1 month plan at 2250, and it is available only 30th of this December. So please subscribe as soon as possible. For subscribing Unacademy Plus, you need to go for bit.ly/IGETCET. So this is the link for getting subscription, and you can even get 10% of instant discount over the plus subscription only when you subscribe for only when you use my code, that is RITESHLIVE. Note the code RITESHLIVE. So this is the code for getting 10% of instant discount over the plus subscription, my dears. Okay. So other than that, we have different plans like we have 6 month plan and even a 12-month plan, and also we have 24 month of plan. So 24 month of plan is for plus 1 student. So if you are from +2, then you can subscribe for a 6 month plan or else a 12 month of plan. 6 month plan is like 11,250 rupees, I mean 1,875 per month, and even a 12-month plan at 13,750, I mean 1,146 per month. Okay. So these are the these are plans we are having plus for you students and the beneficiaries. As I said, premium content at affordable price, structured live courses, dedicated live doubt clearing sessions, quizzes at a regular interval for the self analysis, and batches for the complete preparation, test series, and single subscription for unlimited access. Okay, use my code, don't forget, and note this code, RITESHLIVE. So if you only use this code, then you will get 10% of instant discount over the plus subscription. Or I mean, if you subscribe for 12-month plan of 13,750 rupees, then you will get 10%, I mean 1,375 rupees of instant discount, my dears. Okay, done. So let me move for the session. Okay. So we had a concept regarding Kirchhoff's current law in yesterday's session. I will give a small introduction. Like I will directly go for problem by giving a small introduction regarding this. So it states number of incoming current at the junction. This is the junction is equal to number of outgoing current at the junction. Okay. So if this is incoming current into the junction and this is outgoing current from the junction, then I8 is equal to I4. Okay. Similarly, how many parameters you are having in this figure? So regarding using this, you need to write the equation. Okay. So number of incoming current, that is I8. Similar to I8, what are the other parameters in the figure? You need to write I8 plus I7 plus, like that. Okay. Similarly, that is equal to outgoing. So like I4, here I2 also outgoing, so you need to write down that. Okay. So that is nothing but Kirchhoff's current law. So where it is using, it is using the problematics in terms of I1, I2, I3. um, Before going for the elimination method, we use Kirchhoff's current law so that we will get similar parameters. Similar what parameters means I1, I2, like that. Okay. Okay, so we will go for it next. Then even Kirchhoff's voltage law states algebraic sum of changes in the potential around any closed loop involving resistors and cells in the loop is zero. So I have told we have four conditions here. So if we okay, considering battery, see, that is the battery. Considering battery, if this is battery and my direction from here to here, then we will be what? Similarly, if the same battery, but now my direction is from left to right, then V will be what? you know, we had the same concept in the previous session. Similarly, if we go for resistor, okay, and my direction from here to here and even current direction, that is I from here to here, then V will be what? V is nothing but IR. So IR will be what? Plus or negative. Similarly, same resistor, current direction like this, but my direction from left to right, that V will be what? Again. So how can I find out? Yes, that is an important concept you need to remember. When my direction from left to right in this, okay, from negative to positive, then V will be positive. Okay, remember. Similarly, from negative to positive, but my direction from positive to negative, then V will be negative. Okay, so that you need to remember. Similarly, for the resistor, current direction and my direction is in same plane, then I have to take V's as minus IR. Okay, so similarly here current direction and my direction is opposite to each other, then the condition is plus IR. Okay, so these are the four parameters you need to remember, okay, in Kirchoff's voltage law. And simple, we use the same concept in the sorting out of the problem. Okay, so we can easily do that, right? So we had one problem in the last session. We have completed this problem, right? So to in today's session I will directly go for second one. Okay, so I will go for finding the answer for second one. See here, this is what I need to find. I need to find I1 here. So I1, where it is? Here it is I1. So here it is I3 and I2. Alright. So how can I find? Right. So first you need to do, you have to consider any one direction, whether it would be anti-clockwise or clockwise. Okay, if it is clockwise like this, if you consider here clockwise, then similar you have to consider clockwise here. Okay, then now you relate your direction with the battery and the resistor. Okay, then find the equation, get the equations. Okay, okay, we have done, we got the answer for this yesterday. 0.03, right? Or point something, yes. So this is the answer, I guess, for yesterday's problem. Okay, in today's session we go for this. We need to find I1 value, right? And I have told you my direction I'm considering as clockwise like this. Let me take this as loop number 1 and this as loop number 2. So now let me write for loop 1. Okay, so you name it first. A, B, C, D, E and F. Okay, so loop 1 is nothing but A, B, C, D. Okay, so you have to take like A to B to D to C to A, right? Why can't I take A, C, D, B, A? No, because my direction is from A to B, B to D, D to C to A. So then I have to write like this only. Okay, so now I write the equation for it. So how can I write? Now which is the best color? Okay. So A to B, I am having one resistor, right? So my direction and current direction is same. Then minus I1 into 30. Is it right? Okay. Do it carefully. Then from B to D, I don't have any elements, so neglect. Then D to C, I have one battery, that is from negative to positive. My direction also from negative to positive, that is nothing but plus 40, right? Then we have another resistor, my direction and current direction is the same, so then I need to take minus I, which is the current I3 into 4t, that is equal to 0. Okay, hope you understood, my dear. So if you have any doubts regarding this, please ask me, raise the um, what doubt in the comment section. Okay, I will surely clarify that. So I will sort out this, that is nothing but minus 30 I1 plus 40 minus I, okay, that is nothing but minus 40 I3 is equal to 0. Okay, so I can write 30 I1 plus 40 I3, that is equal to 40. Hi Dhananjay. Sir, when is your class on Unacademy application? Dhananjay, I will conduct one class from on 30th, okay, 30th of this month, then other class on 31st. So only two classes are remaining for this month, December. Then if I get an opportunity to continue in Unacademy application, then I will surely inform you regarding that. Okay, Dhananjay. Okay, super. I will text you through WhatsApp regarding that. So how can I? Okay, so I can write this as 3I1 plus 4I3, that is equal to 4. Okay, so take this as equation number 1. Okay, then I go for loop number 2 now. So which is the loop number 2? This is loop number 2 for loop 2. So how should I write? C to D, D to F, F to E, E to C. Why can't I write C to E? Because my direction is clockwise. So I need to write C to D, C to D, D to F, F to E, E to C. Alright, good. So start from C to D. There is a resistor. So my direction and current direction. See, this is the current direction. My direction and current direction is opposite to each other. So I have to take plus plus 40 into I3. Alright, okay. Then go for battery from positive to negative. That is nothing but my direction from positive to negative. Directly write minus 40. Okay, so then go for D to E. There is no elements in between D to E. Neglect that. Then directly go for F to E. There is one battery, plus to negative. So my direction similar from positive to negative. I can directly write minus 80. Is it right? Then we have one resistor here for 40 ohms. Okay, my direction and current direction. Where is current direction? Okay, current direction and my direction is opposite to each other. Then I have to take plus 40 into I2. Okay, let me solve it. So I will get 40 I3 minus 120 plus 40 I2, that is equal to 0. Okay, so I will take this 122 right hand side. So I can directly write okay, divide by 10 all over. I can directly write 4 I2 plus 4 I3, that is equal to 3. Is it right? Yes, my dear. So the answer is okay. So we have two equations now. Equation number 1 and equation number 2. So what should I do now? So cross elimination method. Let me write two equations first. Okay, which are the equations? First equation is 3I1 plus 4I3 is equal to 0. Okay, so first you do slowly. After you getting the concept, we can directly go for what eliminating simple steps and all. So first you write like this. Then other equation is 4 I2 plus 4 I3 that is equal to 3. Okay, good. So now what I do, these are the two equations I have. But consider here it is 4I3, 4I3, okay. But here it is 3I1 and 4I2. So what I do is I will convert this 4I2 in form of what? I1 and I2. Okay. So how can I convert? See, take this junction. Here it is the junction. So now you need to apply Kirchoff's current law. From Kirchoff's current law, at that junction, I can write incoming current is here. Incoming current is I3, that is equal to outgoing current. What are the outgoing current? I1 plus I2. Alright. So for I2, I can write I3 minus I1. Okay. Good. So what I will do is, so I will directly write here for this 4 into I3 minus I1 plus 4 I3 that is equal to 3, not 4, sorry, that is equal to 3. So 4 I3 minus 4 I1 plus 4 I3 that is equal to 3 again. So here you will get 8 I3 minus 4 I1 equal to 3. Okay. So now what you do is simple. So this is the new equation you got, and similarly you got another equation. Now these two are the two important equations you need to consider. Now go for what? Elimination method. What is elimination method? So you have to eliminate any one term, right? You have I1, I3, I1, I3 here. So what I do, how can I convert? 4I3. Okay. So what I do is I will multiply this with minus 2. Okay. So I will get a new equation. I will get a new equation. Minus 2 means minus 6. Okay. This pen is not good. Okay. Minus 6I1 minus 8I3 that is equal to minus 8. Okay. Then similarly I will write this as same it is. Okay. 8I3. Okay. 8I3 plus minus 4I1 that is equal to 3. Okay. So what I do, I will add up these two. Okay. Then I will get a minus 10I1 that is equal to minus 5. Okay. So I hope I got answer. Yes, 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 good. So I1 is equal to 5 divided by 10. Minus minus. Okay. 5 ones are 5 twos are. The right answer is 0.5 amperes. So which is the right answer? I1 as 0.5 amperes. Is it right? Is it right? Okay. So cross check once before going for the what directly writing I 0.5 as the answer. Let me cross check again. Okay. So here you got first resistor. Okay. So minus is it right? Minus. Okay. Minus same direction. Then we don't have any equations here. Here it is plus from negative to positive. Then we have another resistor that is also minus, because current direction and minus direction is similar, that is minus I3 into 40, so is equal to 0. Okay. So I got answer 3I1 plus 40I3 that is equal to 4. Okay, done. So let me go first loop number 2, where C to D D2, okay. From C to D, my direction, current direction opposite, 40 into I3, okay. Then positive, okay, minus 40. Then here it is again plus 2 negative, minus, okay. Then we had current direction 40 into I2, okay, good. So we had 40 I3 minus 120, okay, plus 40, that is equal to 0. So I can write 4I2, okay, 4I2 plus 4I3, that is equal to 3. 40, 80, 120, good, 3. So we got two equations. uh, I have written two equations, 3I1 4I3, okay. So similarly here also, alright. So then we directly go for a changing up of what, 4I2 in terms of I3 and I1, right? So how can I write for I2, Kirchoff's current law? So this is the junction, I3 is entering, I3 is equal to I1 plus I2, okay. um, so I2 is nothing but I3 minus I1, is it right? Yes, my dear. So after writing I3 minus I1, I3 minus I1 plus 4I3, that is equal to 3. Then 4I1, 4I3, okay. 8I3 minus 4I1, that is equal to 3. Okay, good. So we had two equations. One is, okay. So here it is 2 multiplied with 2, 6I1 plus minus, okay, good, minus 8 on minus 8, right? Okay, similarly for this you remained this as same, second equation, okay. uh, yes. So how can I write same thing? We had two equations, okay. Here is another equation, okay. 8I3, okay, good. Plus 8I3 minus 4I1, that is equal to 3, right? uh, and these two will get cut off when you add up, okay. This is 6 plus 4, 10I1, that is equal to, when you add up here, 8 plus 3, that is minus 5, okay. So I get I1 as 0.5, okay. So the answer is right. So hope you understood, my dear everyone. So simple. So similarly you can go for remaining problems, okay. What I do is today, so I will give two homeworks. You can practice at your home by trying by yourselves, okay. So the first problem, okay. Kirchoff's rule and Kirchoff's numerical, okay. So I have given the diagram. What you need to find, what you need to find, you need to find, okay, values of I1, I2, I3 and I4, everything, okay. So this is the diagram. So we will start from you, okay. Then what I do is, we have two batteries, okay. So from 10 volt battery the current will start, is it right? Yes, of course. So then it will divert like this, okay, like this. Then when it reaches here again it will divert and reaches here. Similarly here it will come, okay. So what happens here? So you have battery here. After comparing, the current generated from 10 volts to here will be very less compared to 5 volt, okay. So you have to write like this, hmm? Then it will come and it will move. So this is the direction of current. So you need to understand how to write the direction of current. When you have, when you are given with the two batteries of different voltage, then the current will start from the higher voltage battery, okay. So what I can write here, it is I1, okay, I2 I3. So what will happen when it comes here? So I have another diagram for that. See here. I2. So I3. See, this is nothing but I3, right? So what is I3? Kirchhoff's voltage current law they have applied. So see here, current incoming I1, that is equal outgoing I2 plus I3. If I take this as I3, okay. So that is nothing but I3 is nothing but what? I1 minus I2, right? Similar. Okay. So then it came you. See here again after reaching here, current I3. Okay. So what I do is I will take this as I3 now. So I3 will come here. Then this junction will be current law. At this junction, current entering two currents. What are the two currents? I2 plus I3. So this current will go here. So that is nothing but this circuit. Okay, simple. I2 plus I3. Okay, so hope I understood. Good. So then when it reaches here, I1 will leave from you. Okay, current I1 will leave from you. So that is only I have written. So I2 plus I3 minus I1, that is equal to 0. Okay, so how I should write? See current entering you, then one of the parameter exited. Okay, the remaining like this. Okay, so when it reaches here again, okay, Kirchhoff's current law, I2 plus I3 minus I1, okay, current entering plus what? Plus I1 plus I2, that is equal to this direction. Okay, so how much? I3, what I got here? I1 get cancelled. Okay, so remaining here it is I2 plus I3. Is it right? No. Why so? I2 I3, okay, minus I1 plus, okay, so this is minus, right? Good. So hope you got that. So ಇದು minus alwa, correct alwa? Okay, so this is also minus, get cancelled. The remaining is I3. Okay, don't make confusions like me in the exam. Okay, so ಕೆಲವೊಮ್ಮೆ ಆಗ್ತದೆ confusions, so tension ಮಾಡಿಕೊಳ್ಳಿ, ಸ್ವಲ್ಪ ಯೋಚನೆ ಮಾಡಿ ಬರೆಯಿರಿ. So that is nothing but I3. So I have written I3 here. Okay, this is how you should apply Kirchhoff's current law for this circuit. Okay, when you have given a lot of resistors and lot of batteries, then you have to write the current distribution first. Okay, properly, then you need to write the what, apply the junction rule at all over the junctions, here, then where it is here again. Okay, here it is again, similarly. So these are the junctions, you need to apply it properly, then you will easily convert those, then you can go for Kirchhoff's voltage law. Kirchhoff's voltage law is similar, nothing, you have to take one direction, any one direction, whether it would be clockwise or anti-clockwise. Okay, if you have taken clockwise here, then take clockwise everywhere. So if you take a clockwise direction everywhere, then you can easily find out. Okay, then anyhow, by comparing a flow of current and your direction, you need to write what a voltage over the each element. Okay, so what I do is I will explain these parameters in the upcoming session, that is on new year, next year. Next year means only 2 to 3 days are remaining, right? So ಹೊಸ ವರ್ಷದಲ್ಲಿ ಇದರದ್ದು ಪ್ರಾಬ್ಲಮ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ತೇನೆ. Okay, so please be present for the next session, and even please don't forget to subscribe for Unacademy Plus, RITESHLIVE. Okay, this is my code to get subscribe for Unacademy Plus, and you will get a 10% of instant discount over the plus subscription, my dears. So don't forget to subscribe for an academy plus, and even please be present for the next session, that is on January 1st 2021. And happy new year everyone for in advance. So please don't forget to share, subscribe, and even kill the like button in the box there. Okay, thank you for joining everyone. I will end up the session, and have a great time. Bye bye. See you all on New Year. Okay, thank you. Bye.